Hey gang! Today I want to just show you guys how to do that last problem on the energy web assign. So let's take a look at the problem. As always, the first thing we want to do is we want to pick out our givens and our unknowns. Alright, so with this problem, it says a 1660 kilogram fighter jet is passing overhead. The jet has an altitude of 10 kilometers and is moving at Mach 1. It further goes on to tell you that Mach 1 is the speed of sound, which is approximately 340 meters per second. All right, so the first thing we want to do here is we want to take our givens and we want to list them down. So that first thing there, that 16,600 kg, that is equal to the mass of the fighter jet. So let's get that jotted down at the bottom there. The next piece of information is an altitude of 10 kilometers. Altitude is just another word for height. It's telling you how high up the jet is. So the altitude is 10 kilometers. The height is 10 kilometers. It says it's moving at a speed that is equal to Mach 1, which is a velocity of 340 meters per second. Now, with these energy problems, something that you're always going to want to keep in mind is that there's usually a hidden given. Something that affects the potential energy, which is gravity. So we know that the gravitational field strength on Earth is 9.8 meters per second per second. So that is all of our givens. So we want to get into solving the problem, but before we do that, we want to check to make sure all of our measurements are in proper units. So going through this, we see 16,600 kilograms. Kilograms is the proper unit for mass. Height is measured in 10 kilometers. You might notice that height is the proper unit is not kilometers, it's actually meters. So the first thing that we're going to want to do is we're going to want to convert kilometers to meters. We know that 1 kilometer is equal to 1,000 meters. So we're just going to set our fence post up here. We have this. Oh man, that was pretty terrible. I'm going to convert 10 kilometers, so that's going to go in my top left box. What I'm turning it into is meters, so I'm just going to make sure we have 1,000 meters here. 1,000 meters is equal to 1 kilometer, so I want to cancel out kilometers, so kilometers is going to go on the bottom so that we can cancel out that unit. And when I do a little bit of magic math, we know that 10 kilometers is the equivalent of 10,000 meters. So now we have that height in proper units. Okay, and that's what we're going to want to use for height moving forward. So what is the first question actually asking me? Well, the first question is asking me, what is the kinetic energy of the fighter jet? So how am I going to find kinetic energy? Well, I want to make sure I'm using my kinetic energy equation. My kinetic energy equation is KE, and that's not an E, KE, see that quick save there, is equal to 1/2 mv squared. And all I'm going to do is I'm going to plug into this equation. So this is for number 1. All right, so the kinetic energy is equal to 1/2 mv squared. So I'm going to do 1/2 the mass, which is 16,600, times your velocity, which we said is the Mach 1, which is 340 meters per second. And what are we going to make sure we do with that? We're going to make sure we square it. All right, so we do a little bit of math using our handy dandy calculator. Don't worry, I'm going to get that right one of these times. KE is equal to 1/2 mv squared. I'm going to plug that in. I probably should have done these calculations before doing this video, but I'm going to get this really big number here. Something like, I'm actually going to type it because it's so big and ugly looking. I get an energy of 959481234 zeros. That many joules. Okay. Usually when you're dealing with things that are pretty large and moving pretty fast, you're going to get an answer that is pretty big because the unit for energy, the joule, is actually a very small unit of energy. So if you're dealing with big objects that are moving really fast, which in this case is a fighter jet moving at the speed of sound, you're probably going to get really big energy. So don't be alarmed if you get an answer that's that big. Okay? So that's what we have for our kinetic energy for the first part. So let's move on to the second part. We want to find the potential energy of the fighter jet at that altitude. So what are we going to use? We're going to use our potential energy equation. pretty straightforward. PE equals mgh. Okay? And all I'm going to do is I'm going to plug into this equation. We have PE equals mgh, so PE is equal to the mass, which is once again 16,600. The gravitational field strength, which we said was 9.8 because we're here on Earth. I don't mean to get technical, but it's actually probably a little bit lower than 9.8, but we can use 9.8. That's okay. Times the height of the object. We're not going to use that 10 kilometers. We're going to use what we converted, the 10,000 meters. Okay? Now that I have that, we're going to take our handy-dandy calculator. We're going to do a little bit of magic math, and we're going to punch those numbers in. We have 16,600 times 9.8 times 10,000. And we get another one of those big, nasty, gigantic numbers, okay? And what do we get? We get oh, come on, man. 16268, and it looks like 5 zeros. 1, 2, 3, 4, 5 zeros. Joules. All right, so that is our answer for problem, emergency, problem number 2. All right, look at number 3. This one's pretty straightforward. All that it wants to know is what is the total amount of energy of the fighter jet. So all you're going to do here is you're going to take your kinetic energy and your potential energy. You're going to add those two together. Well, that's exciting. I'm moving on, guys. This is like my 4th time doing this video, and I'm going to make it work. So all we're going to do is we're going to take those two numbers and we're going to add them together to get our potential energy. All right. So those two add together. 4, 8. 1, 2, 3, 4. I get a total amount of energy of 2, 5, 8, 6, 2, 8, and 4 zeros. That's my total energy. Now, we're often going to refer to this as the total mechanical energy. We haven't really talked about that too much yet, but that's what we call the sum of the kinetic energy and the potential energy. We refer to that as total mechanical energy, okay? That's going to be important for some of the things that we're doing later on in this unit. All right, so we got problem number 1 done. We got problem number 2 done. We got problem number 3. Here's your answer for number 3 up here. I don't want that to be a square. Here's your answer for problem number 3. All right, now let's move on to question number 4. What is question number 4 asking me? It says the fighter jet accelerates at a rate of 21 meters per second squared. All right, so when we see that, we know we're going to have to do something a little bit different for this problem. If the jet accelerates at this rate over a horizontal distance of 10 kilometers, what is the kinetic energy of the fighter jet at the end of this acceleration period? Looks to me like we're going to have to list our givens again for this problem because we have some new items in there. All right, so what I'm going to do is I'm just going to clean up all the stuff that I have over here, and I'm going to have a new place to list some of my givens in. Okay, so my new set of givens. Well, the mass is staying the same. He's staying at the same height. We know that he started with this initial velocity of 340 meters per second. And then what does the fighter jet do? He accelerates at a rate of 21 meters per second squared. All right? He does this over a horizontal distance of 10 kilometers. Since we already converted 10 kilometers, we know that that is going to be equal to 10,000 meters. So I'm just doing the conversion right there. We want to know what the kinetic energy of the fighter jet at the end of this period is. Well, in order to know the kinetic energy, we saw kinetic energy earlier, we know we're going to need to know what the velocity of the fighter jet is. Well, we know what it is in the beginning, but we don't know it at the end of this period. We need to find the final velocity. Can you guys see where this is going? It looks like we're probably going to need to use a kinematics equation. All right, because we have an acceleration, we have a distance, we have a velocity. That's all the signs of using a kinematics equation. So what am I going to do? I'm going to take a look at my notes. I'm going to find what kinematics equation to use. Since I'm a physics teacher, I actually already know. We're going to use VF squared is equal to VI squared plus 2AX. Okay? Plugging into this equation, we don't know what the final velocity is, so we're going to keep VF squared there. It's going to be equal to VI squared. We said VI was 340. Okay? Make sure we square that. Plus 2 times the acceleration, which is 21, times the distance, which is 10,000. Okay? I'll take my handy dandy calculator. We're going to solve for VF squared. I'm going to do some math. See what we get. So it looks like VF squared is equal to 535,000 and 600. Is that the velocity of the fighter jet? No, that's insanely fast. Because what do we need to do? We need to get the square root of each side first. Okay? So once I get the square root of that number, I will know what the final velocity of this fighter jet is. And it looks like the velocity of the fighter jet after accelerating is 731.85 meters per second. Is that the answer for number 4? No, because what did I want to find for number 4? I want to find what the kinetic energy is. So what can I do? Well, I could take this and I could plug it into my kinetic energy equation. KE is equal to 1/2 mv squared. Kinetic energy is equal to the mass of the fighter jet, which we already said is 16,600 times the velocity of 731.8 squared. Ran out of room there, so I didn't put the 5 in. All right, let's plug it in. So I'm going to square that velocity. I'm going to multiply it by the mass, and I'm going to divide by 2. Okay? That actually gives me an answer in scientific notation. We have a really big kinetic energy. Why is the kinetic energy actually bigger now? Well, what happened? The fighter jet is going faster, so we know that the kinetic energy is actually going to get much bigger. So my kinetic energy looks like it is 4.45 e to the 10th joules. It's a relatively large number. Okay? All right, so that's number 4. The next 2 are actually pretty easy. The next one wants to know, what is the total energy of the fighter jet? Well, we talked about how we can find the total energy already. We can find the total energy by just combining the potential energy and the kinetic energy. Did the potential energy of the fighter jet change? No, it stayed the same because it's staying at the same altitude. So I'm going to take my potential energy from the previous problem, and I'm going to add it to the kinetic energy that I have here, and that'll give me my new total mechanical energy. Last one I'm going to leave up to you guys. What is the change in energy from start to finish? Well, you know what the total energy in the beginning was. After doing some addition here, you'll know what the total energy at the end is. You should be able to find the total change in energy. Thanks. Bye.